Hi everyone, my name is Andre. Nice to be here. This is the most awesome setup I saw in a IT conference in the last years. Like, really nice screens here, and I got a timer to remember what to do. So let's talk about. So this is the next one. Let's talk about what we got today. Our agenda is about me and about my company and why all this happened. Then we'll talk about history of ReSec and why it's called ReSec. Deep dive on how things work and what is the profit of using it. My name is Andre. I'm 32 years old. I'm from Rehovot from yesterday, so it was a pretty rough day and night, and we had barely sleep. And now I work at SeedGeek. And SeedGeek, wow, animated, is an awesome company with headquarters in US, New York. It's 9 years old. We got 400 people all over the world. And unfortunately, to describe it in a faster way, I will say that we are the competitor of Ticketmaster. We sell tickets for the live events, sport, all this stuff, mostly in the US and all over the world. And you will say, so why are we here? Because we run fully distributed remote team, not only operations, but development, everything. And it's more than 200 people all over the world. We just dial in when we need to work, and it's like 24/7, and everything is awesome. So the history about ReSec and how it was born. Yeah, we got a logo of DevOps Days, and it's DevOps Days 2016. Because 2 years ago, I was on this really nice conference listening to talks and talking to my friends about technology, and we had really good time, but, you know, we received a pager. And the pager was pretty like generic, saying, well, all your infrastructure is down. Like, all the Yotpo was down. And we got, okay, no more fun talks to you. Let's understand why it happened. And it happened because we're running in Amazon Web Services. And Amazon, like, this is their official logo, but let's be honest. The real logo should be something like it. Because you never know when your instance will be dead and like what will happen. So yeah, some chaos monkey came, and only one instance went down. And this instance was running Redis, our Redis. And like most of the people, system architect and developers will say, okay, like what's the problem? You lost your Redis. No, what's the problem? But if we will look a bit in the history, we will see that not all system architects are thinking about resilience and all the other stuff. And we know a lot of job processing fabrics like Rescue, like Celery, that are using Redis as your job queue. Yeah, arrays for pop, push, and all the other stuff. And we were using Rescue because we were already I'm not saying legacy. We were a profitable shop with API, with the Ruby 1.9, not 1.8, yeah, so it's much better. And our job system was running with Rescue and Redis. And it was not HA for us. You will ask, why? Why don't you use Sentinel? Why not? Because, you know, jobs have to be done. And developers, most of the time, have to do a lot of work on features, on releases, on all other stuff. And when we talk about resilience, they say, OK, something not working, let's hire DevOps. DevOps will solve all our problems, and they will make it work. So yeah, one Redis instance went down, and everything went down. And we said, OK, how can we fix the problem? Because developers don't want, can't, I don't know what other stuff, like why they can't update Redis library to use Sentinel and to leverage it. Let Ops team handle it. And the history is how, like, what was our stack? We were running in Amazon, and our service discovery was Consul. yeah, Consul is really nice. Our jobs were running in Nomad, yeah, scheduler with a lot of abilities, and that was really nice. Security was handled by Vault, so all the secrets were there, and we were pretty safe there. All the instances were, and all the infra was generated with Terraform, and even AMIs were packed with Packer. So yeah, let's say it was a pretty HashiCorp shop. I do love them. But let's think about our major stuff. Why, if we had an auto-scaling group with Redis, master and slave, and master went down, why our slave with all our job data was not promoted and was not updated like with all the system to understand it? Well, two reasons. Probably it was a lame configuration, and I haven't done a really nice job with service check and something else. And yeah, this is the main reason why it happened. So we were in the point of transition of everything working with the console, when console is our service discovery, and we do use it for source of truth, to understand where do we got master, where do we got slave, and if something is dead, how can we handle it? So we thought, how can we do something really, really nice with console to update the record in a console service catalog to have it pointing only to the master. I checked what we had on the market, and there was no working project that was updating based on Sentinel, based on something else, what is your master to be propagated to console. So we said, okay, let's do something really nice. Let's make our own application. And we will call it, like, anyone using console in audience? Hands? Console. Yeah, awesome, console. Console gives us two main interface for service discovery. It can be HTTP, yeah, like most modern application, and for legacy application, it gives us DNS access. So with DNS, we can find every legacy application can just make a DNS request and receive updated records from the service discovery. So, and default for console is service.console. So we thought we can do a project that will be Redis, service, console. And if we, with pointer, no pointer, I don't know how to use it. So when we put everything together, we receive our ReSec. No, pointer is not working. And to glue everything with Go. Why Go? Because it's really nice language. Yeah, you can write things fast. It will not consume a lot of memory, and you know, why not? So we thought about all the things we have to do and how to couple everything together. And this was one of the diagrams of like, how do we do it? Generally, we wrote ReSec as a tiny, teeny sidecar that we run together with every Redis. And when it comes up, it has a couple of lines of configuration with environment variables or anything else. He needs to know what is where is the Redis. We have to add the Redis address. Where is console? What is the name of the service we want to use in a console, and how to do it. So generally, when we do all this stuff, when ReSec starts, it checks a couple of really basic things. First of all, is Redis that is configured for this instance, is this alive? Can it be like, can it handle the requests? And if yes, we have to understand one more stuff. Okay, we got ReSec that is alive. And we got a console service name that should point to the master of our Redis cluster. So it goes to console and checking, do we got a master in console in our service discovery? And if not, if not, we have to leverage one really, really good thing about console, because console, with its Raft protocol and leader election and everything else, gives us the ability to receive distributed lock mechanism that is handled by someone else, but something that I should not take care of. So we're just telling Consul, okay, Consul, we don't have master. Let's just make a leader election, and who will receive the leadership, it will be the master. So all our resecs, they're trying to acquire lock, and because with Consul we can do HTTP long polling and receive, and then the first one will receive the lock, and others will receive the answer with, okay, someone is already handling the lock, you should wait for your next lock. The second we receive the lock, it makes it sends to this Redis slave of no one, like it will be the master right now, and registers is to the console. So now in our service discovery we got a record for our Redis master, and it means that all the watchers that are running on other resecs, they receive the long polling, like the answer to the long polling request, saying, "Hey, I got a new master in your cluster." It means that all the other resecs that are running already or are just starting will receive the configuration to be the slaves of this master. And like when we talk about like starting everything together, it's a really fast leader election. But when we look at the diagram and what happens next, normally I'm running this in a cluster of 3. It means I got one master and two slaves, mostly in different availability zones, because this is how it works. So most of the time, slaves are just running and waiting for master to die, because this is what they do. And here we can see really nice abilities of Go, because in Go we can do multi-threaded, let's say multi-threaded applications with Go routines. When we got a lot of Go routines that every thread is doing their job. One will wait for master to die. Other will check Redis and will update if it's synced, if it's not synced. Maybe it has a lag from the master and all the other stuff. And in Go, with Go routines and channels, we can exchange all this information, and it helps us to write a really straight code that runs together, and not, if we will say about, like, we'll talk about Ruby or Python or anything else, we wouldn't be able to run this like sequentially together. And Go just gave us the ability to run this all. So yep, we're really happy. Links where this stuff is available are in my previous company. I worked in Yotpo when all this happened. Yeah, we'll have 2 minutes for questions. It works. It saved us a lot of pagers during the night. And well, anything else? Thank you.